Hi guys, welcome back to the IPC Flip Classroom. Again, I'm Mr. Hawkins, and today for this lesson we're going to be talking about the law of conservation of mass and using it in terms of chemical equations. Okay, so this is where we get into things like balancing equations, which we're going to learn about today. Okay, so let's take a look at chemical equations. Alright, so you've seen these before in middle school and you'll see them until you graduate. Okay, chemical equations are just a visual representation of things that occur in either the lab or in nature. Alright, so they show what goes into a reaction and what comes out of a reaction. Alright, now the left side of the arrow is called the reactants. Okay, this is something we kind of talked about when we did the worksheet in class using reactants and products. Alright, so reactants are the things that go into the reaction. Okay, and the products are on the right side of the arrow, okay, where the arrow is pointing to, because they come out of the reaction. Alright, they're the products. Now each chemical, okay, that goes into the reaction or comes out of the reaction is represented by a symbol. Okay, now the symbol is a lot like what you would see on our periodic table over there, right? So the periodic table helps us find a symbol to put onto the chemical equation. Now there are other important things that we need to note on these. There's subscripts and there's coefficients, and as you can see on this chemical equation that's before you, with 2H2 and then O2 and H2O, okay? Those contain subscripts and coefficients. Now a subscript is the tiny little number next to the chemical symbol. So for instance, next to O2, okay, that means that there's 2 units of oxygen. Okay, pretty easy. The little subscript tells you there's 2 units of oxygen in that molecule. Alright, now the coefficient is something that's a little bit different. Coefficients are what we use to balance our equation. Okay, we change the coefficients, we can't change the subscripts. Now the coefficients are the big numbers. For instance, next to water, H2O, and the H2 gas, okay, there are these big number 2's next to them, and that indicates that there are 2 units of whatever the molecule is. Okay, so there's 2 units of H2, okay? So originally there were 2 hydrogens, okay? Now that there's 2 units of 2 hydrogens, right? 2 plus 2 is 4, okay? Easy, you got this stuff. So we use the coefficients to balance our equations, alright? And there's a few other pieces of anatomy for chemical equations that we need to note too, alright? Now, on the equation that is on this page, we have these little parentheses G's next to hydrogen and oxygen, and then a parentheses L next to H2O, okay? Now, parentheses G's indicates that whatever the substance is, whatever the chemical compound is, it's a gas, okay? Now, the parentheses L indicates that it is a liquid. Now, there are other ones that we will see throughout this unit. There's parentheses S's and parentheses AQ's, okay? And I guess as you could understand, parentheses S means solid. Now, parentheses AQ is something that's probably new to you. Parentheses AQ indicates that whatever we're dealing with is aqueous, okay? Now, something that's aqueous is dissolved in water, alright? So if I were to take salt and go and stir it into a beaker with water in it, it would be an aqueous solution of sodium chloride, okay? So that's important to note too. We're going to do many examples with that. So how can we use the law of conservation of matter with chemical equations, alright? So again, we know that from the law of conservation of matter, matter can't be created or destroyed. What we start with is exactly the same as what we end with in terms of mass, alright? Now, it may look differently, right? That's probably going to happen. But it still contains the same amount of mass as what we started with, okay? So we use these coefficients to help us balance the chemical equation and make sure that the law of conservation of mass is followed. So let's show an example of the law of conservation of mass. Okay, this is our first example here, okay? And as you can see, we have Mg plus NaCl yields MgCl2 and Na, okay? That means that magnesium and sodium chloride, which is salt, go into a reaction. And we generate magnesium chloride and sodium, okay? Now, how can we balance this, alright? We need to take a look at what's called balancing equations so that they follow the law of conservation of mass, alright? So, let's take a look at each element and make sure that they balance out on both sides of the chemical equation, on either side of the arrow, okay? So on the left side, we have Mg and we have 1 unit of Mg. On the right side, we have Mg and we have 1 unit of Mg also. Okay, so magnesium's looking pretty good right now. Okay, let's take a look at sodium, Na, okay? How many Nas do we have on the left? It would appear as if we have 1 on the left, correct? Okay, now how about on the right? Again, we have 1. Alright, so these are looking balanced. Now, the last one is where things are going to get kind of fishy for us, alright? Let's look at chlorine. Okay, Cl. Now, how many chlorines do we have on the left? We have 1. How many chlorines do we have on the right? Due to this little subscript, okay, our little friend over here, that indicates that we have 2 chlorines. So, on the right side of the equation, we have 2 chlorines, which indicates that these numbers are not balanced, and that is a no-no, okay? We have to have everything balanced in the chemical equation. So, how can we do that, all right? What we can use are coefficients to help balance our equation. Now, where should we add our coefficients? That's where things get kind of interesting, okay? We need to add a coefficient next to wherever the chlorine is so that we can make 2 of them on the left side, okay? So for instance, I'd put a big 2 next to sodium chloride. Okay, that indicates now that there are now 2 chlorines and 2 sodiums, okay? Because this coefficient carries to here and carries to here. So, now sodium is unbalanced on both sides of the equation. As you can see, on the left side we now have 2 sodiums, and on the right side we have 1. How can we balance that out? Well, it's simple. Put another coefficient in front of the sodium on the right. Okay? That changes the sodium to 2, and now we're balanced. All of our variables are in check here. Okay, let's look at a little bit tougher example. Okay, this is an example of the equation that we used whenever we did sodium and water. I'll put a clip of it in this VOD.
If we take a piece of the sodium metal and add it to water, we notice a much more rapid reaction with the water. Like lithium, the sodium is less dense than water and floats. The metal moves across the surface, being pushed by the hydrogen gas that is produced. As you go down the column with group 1 metals, the melting point of the metal decreases. The reaction is very exothermic, which causes the sodium metal to melt.
Now, as you can see, we have sodium on the left added to water to yield sodium hydroxide and hydrogen gas. A few things that we need to note here. Okay, we do have these little tiny indicators of what state these compounds exist in. Okay, so sodium is a solid, water is a liquid. Sodium hydroxide exists in an aqueous solution, which means that it's dissolved in water, and it produces hydrogen gas. Okay, so let's check this and make sure that everything's balanced again. Okay, let's start with everything except for hydrogen and oxygen. You want to end with those 2. So let's take a look at sodium. Okay, the first one is sodium. On either side of the equation, how many sodiums do we have? On the left side of the equation, we have 1 sodium. On the right side of the equation, we also have 1 sodium, okay? Now let's take a look at oxygens. On the left side of the equation, how many oxygens do we have? It would appear as if we have 1. And on the right side, we also have 1, okay? Now, here's where things are going to get really rough for us, okay? On the left side of the equation, we have 2 hydrogens. On the right side of the equation, we have 1 hydrogen here and 2 here, okay? So that indicates that we have 3 hydrogens. Now, as you can see, the sodium's okay, the oxygen's okay, but the hydrogen is unbalanced. Now, how can we help that out? Okay, we're going to use coefficients again to balance our equation. On the left side of the equation, we clearly have less, so we need to add our coefficients on this side. But we need to put it here, clearly, to make things a little more balanced. We could use 3's and 2's here to help us out, okay? Or we could also help us out in an easier way. Alright, so let's put a coefficient right next to the H2O to increase our number of hydrogens. Let's put a 2 next to the H2O, okay? That mixes up our numbers of each element. Okay, so now we have 2 units of H2, which means that we have 4 H's, okay? And we have 2 units of oxygen now. So now things are a little bit iffy for our right side, and our left side's still looking okay, right? So now we should attempt to kind of equalize our right side, all right? we could make this really easy by putting a big 2 in front of sodium hydroxide, okay? Now, that's going to distribute to everything, the sodium, the oxygen, and the hydrogen, okay? They all have 2 units of each other now, okay? So, that's going to change up our number of elements once again. Now we have 2 units of hydrogen plus the H2, which is over here, okay? When we add those together, that's 4, so our hydrogens are now balanced. Now we have 2 units of oxygen, once again, making our oxygens balanced. But now we've thrown a kink in everything where we now have 2 units of sodium, okay? So again, we're a little bit off balance here. But that's an easy fix. We just come over here to the sodium and add a coefficient of 2 next to it. That fixes it up to where we then have 2 units of sodium, making everything balanced, okay? Easy. So why do we do this? Oh, Mr. Hawkins, I don't want to do this. It's awful. I don't have the time for it. It's never going to help me in real life, okay? It actually will. Outside of the walls of my classroom, the law of conservation of mass, okay, and using these balancing of equations is going to help you out greatly, okay? If you plan on taking any kind of chemistry outside of this classroom, all right, and whenever you go to take your EOC in biology, you may be asked to kind of balance some equations or kind of look at coefficients or subscripts. And that's important, okay? So understanding coefficients, subscripts, and how these little yields arrows are, what the reactants are, what the products are very important outside of my classroom, okay? We've seen all kinds of different types of chemical reactions in class already. We're going to see tons more before the semester's out. So as you go along, you'll see more and more reactions, and then you can determine what the reactants are, what the products are, how much of each we need, all kinds of different things, all using the law of conservation of mass and balancing these chemical equations. So important stuff, vital stuff to your knowledge in this class and in other classes. If you have any questions over this content, and I know you might, because it's a little bit higher level, a little bit tougher, okay? So if you do come in for AP or post them in the comment section below, I'll do my best to get back to you as soon as I can, okay? You guys have a great evening, and we'll see you next time.